Welcome to the exciting new world of personal computers. As the new user of an IBM personal computer system, you now have one of the most powerful tools modern technology can provide. You'll soon discover many ways to use this incredible system to enrich your occupation, increase your efficiency, and add to your productivity. But first, you must know how to operate it. With this video program, you'll learn faster than by using only the manuals. As a matter of fact, by the time this program is finished, you'll have learned all the fundamentals necessary for years of successful IBM personal computer operation. We'll start by taking a look at the topics covered in this tape. You'll learn about the various components that make up computer systems. All computer systems use similar components, from that gigantic mainframe system at your local bank to your IBM personal computer. You'll learn how a microprocessor performs most of the same functions as a huge mainframe processor like those found in the big IBM-type systems large corporations use. You'll learn where the brain of your new system is and where it remembers what it's supposed to. You'll be learning the meaning of many new words throughout this program. Don't be concerned the first time you hear a word and don't understand. We'll explain them all in a sequence that will help you understand your computer better. You'll learn the difference between RAMs and ROMs, and why it's important to know the proper file name to get to a file. We'll also cover the disk drive and how to use floppy disks. You'll learn about circuit boards, printers, and modems. You'll understand why DOS is the key to successful IBM personal computer use, and how CP/M can open another world of application programs for you. And most importantly, you'll learn about software and how easy it is for your computer to use software to make life and business easier for you. I know you're anxious to get started, so the first part of this tape will give you some hands-on experience right away. First, you'll learn how to interconnect your IBM personal computer with a monitor and printer. Then you'll learn how to power up your IBM and what the monitor display can tell you about various functions your computer is capable of performing. We'll help you get familiar with your new keyboard and work with some of the additional keys that let you control your computer's potential. There are quite a few new keys on your IBM personal computer that make it different from an ordinary typewriter. We'll go over each of these. You'll then learn about disks and how they should be used and handled. We'll show you how to make copies of disks that you wish to save. You'll learn why it's important to format a disk and how to prevent your data from being erased accidentally. We'll take a look at your IBM personal computer's filing system and how to use file names to get information to and from disks. You'll learn how to find specific files on a disk and how to manipulate files to serve your needs. We'll take a look at the internal software your computer can work with. You'll discover that there are various levels of language working inside your system. You'll understand about those memory size numbers, 64K, 128K, and 256K, and what they mean in your computer. It isn't necessary to know how to program a computer to use its full power. We'll show you how you can use ready-made programs to help your business, education, families, and hobbies. Before you know it, you'll be writing some simple programs and beginning to enjoy the unlimited power your computer can give you. The chapter on programming will show you what a program is and how to write one. By the time you're finished with this tape, you'll be well on your way to mastering this amazing new tool. Just remember, you're in control. Your IBM personal computer system is now going to follow your commands and open a whole new world of information and excitement for you. Before we begin, we would like to mention that this tape is not designed to replace the various manuals you received with your IBM personal computer. This tape is designed to help you begin to use your system right away, while you're viewing this tape. You'll have a very solid overview of your new system when you finish this tape, and will then find the manuals far more helpful. As we proceed, there will be times when it would be helpful to pause this tape and try one of the exercises. When you see this symbol appear on the lower right-hand corner of your television screen and hear these 3 beeps, it's time to put your video player in pause Then try that particular exercise just described. When you feel that you understand it and want to continue with the tape, simply come out of pause on your video player and proceed. If you feel that you don't quite understand an exercise and want to go back over the explanation, simply rewind this video program back to the beginning of the section that you want to review and look at it again. We'll be presenting quite a bit of material for you to learn. If it seems to be coming too fast for you, use the pause and rewind features of your video player as often as you want. You may find it helpful to jot down your video player's counter numbers as you go. That way you can review specific sections more easily, and review them again in more depth after you've used your IBM PC for a while. The back of the box that this video program came in has a column for you to write down the counter numbers. Perhaps the most useful numbers to begin with are those that correspond to the beginnings of each chapter. Soon you'll be assembling your system. It's time to bring your computer close so this program can help you begin to use your computer. Gather all the elements listed on the back of your video program package next to your video player and television set. Here's the pause symbol at the end of Chapter 1 to give you time to write down your counter numbers for the beginning of Chapter 2. Get ready to begin. In this chapter, you'll get a look inside of your IBM personal computer. You'll learn how the circuits on the inside relate to the hardware on the outside. The first so-called personal computers were largely do-it-yourself devices. In the mid-1970s, several manufacturers designed kits made up of electronic components that had to be assembled before any actual computing could be done. Since these kits tended to be incomplete and had to be built, most people who were not electronics hobbyists didn't get involved with personal computers. However, one thing in common. They were based on the development of a new kind of electronic device called a microprocessor chip. It is this microprocessor device that made the whole personal computer revolution possible. Everything changed in the late 70s. Several manufacturers began shipping a kind of personal computer that could be used right after unpacking from its box. The personal computer revolution was born. IBM, the world's leader in huge mainframe units, recognized the need for a small and compact, yet very powerful personal system. Your IBM personal computer is the result of thousands of man-hours of development and design from a company that has pioneered computer technology. All of the work that your personal computer does is done under the control of the microprocessor. It may look tiny, however, it contains thousands of transistors arranged in a specific way so that it can control your entire system. We're going to show you the inside of your IBM personal computer to give you some idea of what goes where. We don't recommend that you actually open your own computer because it is factory assembled and checked out when you receive it. But what we are going to show you looks exactly like yours. On the upper right side of your IBM personal computer is the power supply. It is a sealed unit and provides the various voltages your computer needs for its various circuits. Don't ever tamper with the power supply. Doing so might be dangerous and void your warranty. The power supply contains a fan to keep it cool. In front of the power supply are the disk drive assemblies. These are the components that allow you to record the data that you generate onto floppy disks. If you have a second disk drive, it will be located to the right of the first drive. Directly under the disk drives is the main circuit board, a circuit board that contains many small electronic components called ICs. IC stands for Integrated Circuit. On the main circuit board, as well as on the separate memory board, are many of these ICs. The smaller ICs handle memory functions. There are several large ICs in your computer. They control various functions such as video display and the disk drive operations. One of the large ICs with many flat wires attached to it is the brain of your IBM personal computer. It contains a microprocessor chip. It is also known as the CPU, or Central Processing Unit. As the brain of your computer system, the CPU is one of the three essential elements common to every computer system, no matter how large or small. These three essential elements are the CPU, or Central Processing Unit, the memory, an input and output. Basically, any computer system fetches instructions from a memory, performs those instructions, adds information if required from input devices, and displays or transmits the results of that process through output devices. You may want to take a look at that whole concept again. It's the core to understanding how all computers work. Your IBM personal computer contains all of the basic elements and performs all the basic functions much in the same way as that big mainframe computer does at your neighborhood bank. Those rows of smaller IC chips inside your IBM personal computer contain the memory where instructions for the CPU are stored. There are two types of memory inside of your computer, non-volatile and volatile memory. Non-volatile memory is made up of special ICs that have been pre-recorded with program information at the factory when your IBM personal computer was manufactured. The IC components that make up the non-volatile or already recorded memory section are known as ROMs, for read-only memory. These pre-programmed chips give your IBM personal computer its special abilities. ROM is unforgetful or non-volatile. Volatile memory is stored in chips known as RAMs, for random access memory. It is these RAMs that you write into when you're working with your computer. Since the contents of RAMs can be written into or read out from, they are the memory chips that you will be using when you are using your computer. But they will also forget that information when you turn your IBM personal computer off. Volatile memory is forgetful memory. These chips are essentially empty until you load information into them when you're operating your computer. On the upper left-hand side of the main circuit board of your IBM personal computer is a row of 5 electrical receptacles known as expansion slots. They are also called peripheral connectors. These slots are available for various input-output devices and additional memory circuit cards. Essentially, they allow the computer to grow and expand with your needs. The disk drive or drives that are in your computer unit are also known as peripherals. A peripheral is any device connected to your computer that serves an input or output function. Other kinds of peripherals may be a printer, to output information and data onto a piece of paper, a hard disk for expanded memory capability, a modem, a device used to connect your IBM personal computer to another computer, usually through telephone lines, a plotter to physically generate those maps, charts, and graphs, or a touch pen to quickly input messages to your computer with a simple touch of the display screen. Some of these devices are input devices only. Others are output devices only. Some are combination input-output devices. The keyboard is one of the input devices available to the CPU. The monitor is one of the output devices your computer uses to communicate with the outside world. A good example of a combination input-output device is a disk drive. Instructions or data can be written or magnetically recorded onto the so-called floppy disk through the drive. This is outputting data from your computer. Instructions and data can also be read or played back from the disk to your computer. This is an input function. Another way of saying write is save, and another way of saying read is load. You may save data on a disk by writing onto that disk magnetically, and you may magnetically read data from that disk by loading it into random access memory, RAM. As the personal computer industry grows, new kinds of devices are being developed for new applications. There are many adapter circuit boards or cards currently available for use in any of the 5 peripheral connector slots inside your computer. Many independent companies are producing these plug-in boards for a variety of uses. You may or may not have some of these. However, you'll most certainly have one of 2 IBM video display cards. There is the IBM monochrome display parallel printer adapter. It is really 2 different circuits on one board. One of these circuits is where you would connect the IBM monochrome display, if you're using one. The other circuit is where you would connect an external device requiring a parallel output, such as parallel printers. The other video display adapter card is the IBM Color Graphics adapter. It is used for any kind of video display other than the IBM monochrome display. You'll need this card if you want to use another manufacturer's green screen, or black and white video display, or a TV set, or what's known as an RGB display monitor, short for red, green, and blue, the component color signals of video. This card has two connectors. One is where you would plug in to get a standard video signal. The other is where you would plug in an RGB color monitor. If you're going to be using a true color monitor or a more sophisticated RGB color monitor, you'll be using the composite signal connector or the color direct drive connector to connect your display device. Incidentally, your green screen IBM monochrome monitor is really a black and white television monitor with a specially designed display screen that turns the white characters into green characters. The green color has been found to reduce eye strain. If you're using a standard television receiver, you'll need an RF modulator to convert the video signal from your computer to a television channel signal that can be tuned in on your receiver. The instructions in the manuals that came with the device. So far, we've been concerned with the system unit, the display device, and the keyboard. These parts are called hardware, the physical components of your computer. The actual instructions that your computer uses and the data or information that it processes is called software. We'll deal with software in more detail after you've assembled your system and turned it on. This chapter should have given you a better understanding of the hardware components of your system and how they relate to one another. Here's the pause symbol to allow you to pause and mark down your video player's counter numbers for Chapter 3. The pause will appear at the end of each chapter. In this chapter, you'll start your first hands-on experience with your new IBM personal computer. First, we'll review the way you should have the hardware interconnected for proper operation. You'll connect your keyboard and video monitor and do the power-on test of your system. Right now, we'll interconnect your keyboard and video monitor. Be sure that you don't have any power cords plugged into any electrical outlets at this time. We'll show you when to plug them in. In this computer, we have an IBM monochrome display adapter and the IBM color graphics adapter in their respective slots. Turn your computer around so you can work on the back panel where the connectors are. Now, find the video cable that comes with your IBM video monitor. It'll be the cable that has 6-pin connectors enclosed in a frame like a D on both ends. If you look carefully, you can count 9 pinholes inside of the D-shaped enclosure. If you're using the standard IBM monochrome display card, your dealer will usually have put it in slot number 2 for you. Plug the end of the cable with a 9-pin D connector coming from the monitor into the matching connector on the back panel of your computer. Again, be sure you don't have the main power cable to your computer itself plugged into any electrical power. Your IBM monochrome display will get its AC power from the connector on the back of your computer. Plug the electrical power connector from the IBM monitor into the auxiliary power connector on the far left of the back panel of your computer. If you're not using an IBM monochrome display, you can use another manufacturer's black and white or green screen video monitor. If this is the case, find the cable that has phono connectors on both ends. It'll look just like those cables used on videocassette or stereo equipment as we show here. Plug one end of the phono cable into the phono jack on the back of your monitor. If there is a switch labeled 75 ohms or terminate, be sure to switch to the 75 ohm or terminate position. Your dealer usually will have installed your color graphics monitor adapter into slot number 3. It will look like this. If it is in another slot, it will still operate properly. Now plug the other end of the phono cable into the phono jack on the back of your computer, as we show here. Monitors and display devices other than those made by IBM will have to be plugged into a properly grounded outlet other than the power connector on the back of your computer. Find the AC plug for your monitor now and plug it into such an outlet. If you're using any other kind of display device, such as a TV receiver or a RGB color display, refer to the options sections of your Guide to Operations manual for the proper installation and connection procedures. Now connect the connector coming from the keyboard into the connector labeled Keyboard on the back of your computer. You'll have to turn it until the pins feel like they match up and the notch on the top of the plug matches. Then push firmly in. Be sure you use the left-hand keyboard connector, not the right-hand cassette connector. Don't ever force any connectors on. If they don't feel like they should go in with moderate pressure, you probably don't have them aligned correctly. In that case, take a second look. The keyboard connector is a very handy feature of your IBM personal computer. It allows you to reposition the keyboard to suit your own comfort and is a feature not found on most personal computers. In fact, you can even change the angle of your keyboard as it sits on a table by turning the keyboard foot controls located at the right and left side of the keyboard. To raise the feet again, simply press in the control as you turn it clockwise. Finally, be sure the power switch on the right-hand side of your computer is turned off, as we show here. Plug the rectangular end of the AC power cord into the receptacle on the left-hand side of the back connector panel of your IBM personal computer. Again, make sure the power switch on the right-hand side of your computer is turned off, and if it is, plug it into a properly grounded three-pronged electrical outlet. If you have to use an extension cord for the computer power cord, make sure it's the kind with a three-prong connector and that it's properly grounded. Notice that we have plugged into this box. This is a surge protector and is available from most computer dealers. It is used to protect your computer from high-voltage power surges that may come through your power cords from time to time. These surges can cause a loss of data or completely stop a program from running properly. In some cases, they can actually damage integrated circuit chips. A recent study showed that the average business or home receives about 3 such hits, as they are called, a day. Now position your computer, monitor, and keyboard in a way that is most comfortable for you to operate. By now, you should have everything connected together and plugged into electrical power. In order for you to use this video program comfortably for the remainder of your training, you should have your computer system and your video player and TV set arranged something like this. In this program, we'll be using 2 disk drives. We assume that you have at least 1 disk drive installed in your system. If you don't have a second drive now and are planning to add one in the future, your dealer can help you with installation. Since most users like to have printed copies of the work they do with their personal computers, a wide range of printers have become available. Some printers require what's known as a serial interface adapter, others a parallel interface adapter. Serial means that the data is fed to the printer one character after another. Parallel means that the data used to tell the printer to form characters is fed on 8 wires at the same time. Later, in Chapter 7, you'll learn the significance of 8 bits of data. For now, just think of an 8-lane freeway feeding traffic into a city as opposed to 1 country lane handling traffic 1 car at a time. If you have a printer with your system, your dealer should have installed the correct adapter card for you and configured your system for the type of printer you have. If you have an IBM 80 CPS matrix printer or other parallel printer, you can use the combined monochrome display and parallel printer adapter that we discussed earlier to connect your printer to your computer. If you have a serial printer, you'll need a serial adapter card plugged into one of the 5 peripheral slots. If you want further information, check your Guide to Operations. There should be an insert in the printer or options section that came with your printer adapter card. Of course, your dealer can give you more help too. Now it's time to turn on your computer. The first thing you'll do is perform the power-on self-test to make sure that your computer is functioning properly after shipping. The self-test will take anywhere from 3 to 45 seconds, depending on how much memory your computer has. The self-test is a very useful feature. First, it eliminates the chance of damaging any data that you may have stored on a disk. Second, if there is a problem, it will help a service technician identify it. Go ahead now and reach around the right-hand side of your computer and turn the power switch on and watch your display screen. Then, in about 4 seconds, a small horizontal white line will appear in the upper left-hand corner of your screen. This line is called the cursor. The cursor will become more familiar to you very soon. After a short time, you'll hear a short beep and the left-hand disk drive will begin to whir. It will stop, then whir again for several seconds. Then the following display will show on your screen. Now is a good time to adjust the brightness and contrast controls on the data display. Those are the two knobs to the right of the screen. Adjust the controls so you can read the display clearly. If you didn't get any or all of these three responses, the cursor on the screen, the short beep, or the display, you may have a problem with your system. If this is the case, turn the power to your computer off and wait 30 seconds before you turn the power back on. Some IBM PCs will reset in a shorter time. You'll have to experiment to find the shortest recycle time for your computer. For now, wait about 30 seconds. Then turn the power switch back on. Watch and listen for those three responses. If you still don't have any one or all three responses, you'll have to run through the problem determination procedures that are contained in your guide to operations. Along with these procedures, there's an excellent diagnostics program that comes on a disk in the back of your guide to operations. The guide can give you more information about running this disk program if it's necessary. These procedures are an excellent way to pinpoint the location and/or cause of a problem that can be very helpful to you. If you do have a problem, go ahead and check the problem determination procedures now. Come back to this video program when this display is showing on your screen. In this chapter, you've learned external assembly for IBM Personal Computer System. You have learned about some of the adapter cards available for your computer and the difference between parallel and serial data handling. If you do have this display now, you're ready to move on to Chapter 4 and learn about your new keyboard. In this chapter, you'll learn how to use the keyboard and how to read some of the screen displays on your new computer. For the time being, we won't be working with disks. Your computer has enough power without a disk in its drive to help you learn about the keyboard. We'll add disk operating procedures in the next chapter. As you begin to practice with your computer, don't be afraid to press any of the keys. There is nothing you can do from the keyboard that will cause any major problems. Many people are afraid of pressing a wrong key for fear of doing something to their computer. Don't be afraid. The worst that can happen is that you'll have to start a program over. Let's start with a brief overview of your new keyboard. Obviously, there are more keys than on a standard typewriter. However, as you begin to operate your computer, you'll discover that those additional keys really do help make your work easier and faster. Notice that in the center area there are lighter colored keys that have most of the same characters and layout as a standard typewriter. These are used much the same way as you would use a typewriter. Around the outside of the light-colored typewriter-like keys are a group of darker colored keys. These are used frequently to give instructions to your computer while you're running programs. These keys are sometimes called modifier keys and help change or modify the function of other keys on your keyboard. We'll examine and use each of these in a moment. On the far right side of your keyboard is a group of keys known as the numeric keypad. In addition to the numbers 0 through 9, there are keys labeled with the plus and minus sign, a decimal point, and a large key at the top labeled numlock. Notice that most of the keys on the numeric keypad also have symbols on them, such as the 7 key, which has the word home, and the decimal key with DEL for delete. We'll run through some exercises with those keys later. Finally, on the far left is a group of 10 keys known as program function keys. They are very useful when you're running programs. We'll be more specific about these later. Right now, be sure your system is powered up and that this display is on your screen. You are now going to do an exercise with 3 of the keys. Find the key labeled CTRL. This is known as the control key. Hold it down with your left forefinger. Now find the key labeled ALT. This is the alternate key. While you're still holding the control key with your forefinger, press the alternate key with your left thumb and hold it down. Now find the key labeled DEL on the right-hand side of your keyboard, the same delete key we just looked at a moment ago. While you are holding the first 2 keys down with your left hand, press the delete key once. Notice that your display cleared and your computer acted the same way it did a few minutes ago when you first turned it on and ran the power on self-test. Only this time it didn't take quite as long. Finally, the first screen display returned to where it was when we started this chapter. You just performed what is called a system reset. When you held down the control key and alternate key while you pressed the delete key, you told your computer to lose all the contents of random access memory, RAM, and to reload all the permanent data that stays in the ROM back into RAM. In effect, you reset the entire system to the state that it was in right after you had powered up. If you had been working on a program and had a lot of new information in memory when you did the system reset, you would have lost it forever, unless you had previously saved it on some external memory device. The control key you just used is always used in conjunction with some other key to perform some specialized function. Go ahead and type a few letters. Now, hold down the control key and press the key labeled Home. Notice that the upper part of your screen cleared and the cursor moved to the upper leftmost position. That position is known as the Home position. The function you performed is known as a control function. You'll run across other combinations of control and key functions as you begin to run software on your computer. In fact, in many pre-written commercial programs, you'll see this symbol with a letter or a letter inside of square brackets to signify that you must hold the control key down while you strike the designated key to perform a specific command. Right now, you should have the cursor at the upper left-hand corner of your display, the Home position. It is flashing, waiting for you to tell it something. It also shows you where on the screen the next character you type will appear. Now press any letter key and hold it down. Notice that the letter prints on the screen at the cursor, pauses for a moment, then keeps repeating as long as you hold the key down. You'll find this a very useful feature later. This automatic repeat is available on all the keys with letters, numbers, and symbols. But because the keys have automatic repeat, you could find you have more than one letter or command because you held the key down too long. Now type a row of characters across the length of the screen and continue typing when you get to the end of the row. Notice that the cursor came to the end of the row and then continued the characters that you were typing on the next line. This is called wraparound, and it means you don't have to press any keys when you come to the end of a row, the way you might have pressed return on a typewriter. Your computer is capable of displaying 25 lines of up to 80 characters per line. It also displays upper and lowercase letters. The shift keys at each end of the keyboard function just like those in a typewriter. While holding down either shift key and striking another of the letter keys, the uppercase or capital version of that letter appears on your display. If you want to continue typing all capital letters, you can lock the letter keys into uppercase by pressing the caps lock key on the board and then typing. To unlock it, simply press it again. Do this now. There is one particular characteristic of the caps lock function that you should be aware of. If you have the caps lock key on for typing all uppercase letters and hold down either shift key and type a letter, you'll get a lowercase letter. This will continue while the shift key is held down. Try it. The symbols that appear on the top of the number keys and on top of some of the letter keys can only be used by pressing the Shift key. The caps lock key does not control their use. Perhaps the most frequently used key on any computer is the Enter key, and it's the most important. On your IBM personal computer, it is the key toward the right-hand side of the keyboard that has this symbol on it. It is sort of like the period at the end of a sentence. It tells your computer you have given a command, and here it is. Some computer manufacturers call it a return key. Now go ahead and type the first few letters of the alphabet. Then press the Enter key. You told your computer to recognize A, B, C, D, E, F, etc. It doesn't recognize that as a command, and it isn't programmed to do anything when it sees that combination of letters followed by an Enter command. And so it responded with a syntax error message. Basically, pressing the Enter key is a signal to the CPU that you want the computer to understand and act on the message you have just typed in. However, your computer must be programmed to understand the command you're giving it. Since you typed no recognizable message, you got this message back from your computer. Syntax error. However, it's a very forgiving slave, and it also said, I'm still okay. Try something that I'll understand. That OK message means that Programming Language Basic is loaded in memory and will understand commands that it has been programmed to understand. It's up to you to give it a command it understands. Incidentally, the version of the Language Basic that is loaded now is called Cassette Basic and is programmed into ROMs in your computer at the factory. There are two other levels of BASIC available to you when you're using disks. DOS Basic can be loaded from a disk, as can DOS Advanced Basic, called Basic A. Don't be too concerned about languages right now. We'll cover them in more depth in Chapter 7. You may have noticed that there are several new symbols that don't appear on an ordinary typewriter keyboard. Those symbols are the vertical dashes, the backslash, the tilde, the grave accent or reverse apostrophe, square brackets left and right, braces left and right, angle brackets left and right, and the caret or circumflex. Many programming languages use these symbols for various functions, and they add to the versatility of your computer. In most programs involving mathematics, it's necessary to use a symbol for multiplication and a symbol for division. The asterisk is usually used for multiplication, and the forward slash is used for division. The numeric keypad has numbers laid out like a calculator or adding machine, and allows you to enter numbers faster than by using the top row of number keys on the main keyboard. Although both sets of keys will enter numbers, you have your choice. Find the numlock key at the top of the numeric keypad. When you press the numlock key once, the numeric keypad lets you type numbers. Press it again and the functions marked on the number keys take over. This numlock key is like a toggle, an on-off switch between the numbers and the functions. The decimal point key and the 0 key are also toggled on or off with the numlock key. Take a minute now to practice using the numlock key and all the keys on the numeric keypad to see what they do. Now would be a good time to mention the letter O and the 0 keys. Your IBM needs a way to distinguish between the letter O and the number 0. You should be careful that you don't type O when you mean 0 or vice versa. A program expecting a value 0 will not recognize the letter O as anything other than what it is, the letter O. The same is true of the number 1 key and the lowercase l. From your typing habits, you might try to enter a lowercase l when you mean the value 1. Again, your computer can't tell you mean a value 1 if you actually type it as the lowercase letter l. This could be another time when a program might not run correctly. Now press the key labeled Home. It is also the number 7 key on the numeric keypad. If you see the number 7 appear on your screen at the cursor, toggle the numlock key and press Home again. Notice that your cursor moved back to the home position, but that nothing was erased from the screen. Since you didn't hold down the Control key when you pressed the Home key, you told your computer to return the cursor to the home position but not to erase any characters on the screen. You've already used the Control key, the Alternate key, and the Shift keys. They are modifier keys because they modify the function of other keys. This is an important point to remember because you'll use the modifier keys frequently. The Control key is probably the most often used modifier key. Remember, to use the Control key, you hold it down and keep it down while you strike the other key. The Alternate key is used with the letter A through Z keys to enter words in the language BASIC. Try it. Press the Alt key and then press 3 or 4 letter keys. You won't need this particular use of the Alternate key until you get into programming. The Tab key functions much in the same way it does in a typewriter, moving the cursor a predetermined number of spaces. The Tab key on your IBM personal computer is set every 8 characters. In addition to the keys, your space bar is an important part of the keyboard. You'll find that the location of spaces can be vital to successful programming and operation. Once you get to the point that you're copying someone else's program from a printed list, pay particular attention to where the spaces are located and be sure you place them in the same spot. A program might not run correctly if spaces are placed wrong or don't exist. Now we'll show you how you can correct typing errors, then give some time to try out all the keys we have just mentioned. Use your down arrow key to move your cursor down to a new line. Remember to toggle numlock if you need to. Go ahead and type about a half a line of letters. Use the left arrow key to move the cursor to the left over some of those characters. Now start typing different letters over the old ones. Notice how the new letters replace the old ones. Now type the line, "Now is the time for all good." Oh well, we better go back and correct the word "for." Using the cursor movement or arrow keys, move the cursor back until it is on top of the letter I in the word "for." Then type the letter O over the I. Now move the cursor back over to where you left off using the right arrow key and continue to type. When you come to the end of the sentence, stop. You corrected the error in the word "for" by backspacing the cursor, overstriking the letter, and using the right arrow cursor movement key to move the cursor back to where you left off. Another way of correcting typing mistakes is by using the delete key. Go ahead and type a few more characters. Now move the cursor back under the last character you typed and press the delete key. Notice that the last character disappeared and the cursor is flashing at that position, ready for you to type in a new character. An even easier way to delete characters is with the backspace key. Type a few more characters. Now press the key on the top row of the keyboard with the arrow pointing left. It is the backspace key and will automatically erase the last character to the left of the cursor with each keystroke. You may also insert characters into an already typed line using the key labeled INS underneath the number 0. Clear your display right now by holding down the Control key and pressing the Home key. Now type another line of characters. Move your cursor back under several characters and activate the Insert key by pressing it once. Notice that the cursor has changed shape. It's now a box rather than a line. This box tells you that your computer is in the Insert mode. Now type several letters or words. Notice that as you type in new characters, all of those characters to the right of the cursor move to the right, making room for those new characters. You've inserted new characters into an already typed line. With the cursor still where it is, toggle the Insert key off and continue to type more characters. Notice that with the Insert key turned off, each new character you type replaces the previously typed character. These functions that you've been performing to correct your work are usually called edit functions. They allow you to edit or change your work, to correct your mistakes quickly. Another key which can help you edit is the Escape key. Now press the Escape key. Notice that when you press the Escape key, the entire row that you had typed disappeared from sight. Your cursor is now waiting for you to type in new characters. You may be wondering what happens when I type down at the bottom of the screen. Go ahead and try it. Type several characters, then press the Enter key. You'll get an error message, then a line which says OK. Do this several times until the cursor is down at the bottom of your display. Continue to type characters, then press the Enter key. Notice that as you need more vertical space to type more lines, the screen display moves up a line at a time to give you more space. This is called scrolling. You could actually move all of the text up and off the screen if you were to hold the Enter key down. The key in the upper right of the keyboard labeled Scroll Lock, when used with the Control key, will also scroll the screen and move everything up. Hold down the Control key and press Scroll Lock until your screen is clear. Notice that your cursor is at the bottom of your screen. In some programs, the keys labeled Page Up and Page Down will allow you to scroll your entire display up or down. You'll find this quite handy later. A little later in this video program, we'll show you how you can save data that you have typed onto a disk so that it won't be lost if something happens. Another way to save work you may be doing is to have it printed out on a printer. There is a key labeled PRTSC. It means print screen. Basically, it allows anything on your display screen to be printed on a printer you have connected to your computer. To use the print screen key, you must first be sure your printer is connected properly, turned on, ready to print onto paper. You must hold the Shift key down while you press the print screen key. Once you've done this, your computer will, in effect, take a snapshot of the particular screen you have displayed. As we said earlier, you can't really damage your computer by striking any keys on the keyboard. However, there could be a problem if any liquid or powder gets spilled onto the keyboard or disk drive. This could cause your computer to malfunction. Watch what you do with your coffee, tea, or soft drinks when you're near your computer. You might want to spend some time practicing with your new keyboard. Go ahead now and get yourself familiar with the keys or review this chapter. In the next chapter, you'll learn how to work with your disk drives. In a few minutes, you'll start to use floppy disks and your disk drive. Right now, though, we'll go over the proper way to care for and use disks. Turn the power switch to your computer off for the time being. You'll turn it on again shortly when you start to use disks. For now, though, you'll learn the proper care and handling of floppy disks. A disk drive is a combination input-output device. Programs and data can be read or loaded from a magnetic floppy disk, and programs and data can be written or saved on a disk. The disk drive unit is nothing more than a specially designed tape recorder for handling data. Your IBM personal computer is capable of using an audio cassette recorder to load and save programs and data. Early personal computers depended on audio cassette recorders to store data before disk drives were available. However, because an audio cassette recorder depends on a long piece of tape to record or play back its contents, it takes a long time to read from or write on it. This also makes it difficult to find places on the tape where specific programs were stored, since the only reference on a continuous length of tape is the beginning of that tape. Another advantage to a disk system is the capacity of disks. One floppy disk that you will use with your IBM personal computer can hold about as much information as 106 pages of a book. For demonstration only, we have taken this disk apart to show you the inside. We don't recommend that you open a disk yourself because it will ruin it forever. And never touch the disk surface directly. If you do accidentally touch the disk surface, make a backup copy of that disk as soon as you can. Sometimes the oil from your fingers could eventually cause problems with that disk. The floppy disks that you will use with your computer are really just plastic disks coated with a magnetic coating similar to the magnetic coating on an audio cassette. Because tracks can be laid down in a circular manner, side by side on a disk, you get to different sections of the disk very fast. Your IBM uses a technique of laying tracks in such a way as to get the most efficient use of space on the disk. This is called density. The disk you will use should be double density. When you're buying disks, you need to specify double density. To make it even easier to find specific places on a disk, the disk is further divided into sectors by magnetic coating. The coating of the sectors magnetically means that disks for your computer are known as soft-sectored. Some disks for other manufacturers' computers use what's known as hard-sectored disks. On those, the sectors are identified by a series of holes punched into the disk. When you purchase new disks for your IBM personal computer, you should look for soft-sectored double-density floppy disks. Hard-sectored disks won't run on your machine. In addition, it's possible to save and load data on both sides of a floppy disk. For now, just remember that if your disk drives are 160K drives, you can only use one side of the disk. If your drive or drives are 320K drives, your computer uses both sides of the disk surface. When you're purchasing new blank disks, you must specify that they should be soft-sectored, double-density, double-sided if you're using 320K drives, and soft-sectored, double-density, single-sided if you're using 160K drives. Actually, double-sided will work with 160K drives, so you're safe with them for either size drive. However, single-sided won't work on 320K machines, so you should play it safe and purchase double-sided when you need additional disks. All disks are permanently enclosed inside of a plastic cover that has access holes in it for the disk drive to make contact with the disk. Disk allows it to rotate freely and helps keep it clean. Disks must be handled with extreme caution. Never write directly onto the plastic cover with a ballpoint pen or pencil. Put no pressure on the cover or the disk itself. The proper way to label a disk is to write on the blank label that is supplied with the disk. Then carefully attach that label to the disk. When you do attach the label to a disk, make sure that you don't cover the notch on one edge of the disk. That notch serves a very specific purpose that we'll explain later. If you do have to write directly on a disk, use a felt-tip pen and write very lightly. Disks should never be placed on or near anything that generates a magnetic or electrical field. Keep your disks away from telephones, television sets, or stereo equipment. Don't set your disk on top of your IBM personal computer monitor, and don't set your telephone on top of a disk. Don't ever touch the gray or brown surface of the disk itself. Always try to store your disks in the treated paper packet that came with it. It helps to prevent static buildup on the disk, which could then attract dust. And try to store your disk vertically in any one of several holders that are available for this purpose. Extreme temperatures can be dangerous to disks. Keep them out of the sun, as they could warp or lose data. The first visible sign of damage to a disk could be warping or bending of the disk cover. However, the disk could have already lost data if it was near a magnetic field. Disks can last more than 40 hours if a reasonable amount of care is taken with them. 40 hours is a long time when you consider that they're used for only a few seconds when you load or save a program. A disk will operate only if it's inserted in a drive correctly. A good rule of thumb, so to speak, is to hold the disk so that your thumb is pointing at the manufacturer's label as we show here, with the large oval cutout on the top of the disk pointing toward the drive. Then open the door to the drive and keep the disk as flat as possible. Gently push the disk into the drive until it stops. Never force your disks into the disk drive. If you meet with any resistance at all when you're pushing the disk in, take it out gently and try again. Make sure you're inserting it with the label up and facing away from you towards the drive unit. Once the disk is in as far as it will go, close the door to the drive. Don't force the door closed. If you meet with any resistance, take the disk out and try again. Sometimes carefully centering the disk inside of the hole in the plastic cover will allow the disk to go in properly after a first attempt has failed. Don't ever insert or remove a disk while a drive is running. You can tell it's running by hearing the whirring and clicking sound coming from the drive, or by seeing the red light glow on the front of the drive unit. In order to use disks, your computer needs additional information in its memory. It needs to know how to handle data coming from and going to the disk drive and its disk. And it needs to be able to interpret various languages that the programs contained in that disk may use. In other words, it needs a disk operating system. Some people call it DOS, others simply DOS. We'll refer to the disk operating system in your IBM personal computer as DOS in this video program. Your computer needs to have all of this DOS information loaded into its random access memory before it can let you use a program contained on a disk. But DOS must be loaded from a disk before your IBM personal computer can use a disk. It's kind of a catch-22 situation. In order to use disks, your computer must have some of the information contained on the disk to operate properly. How then does it get that very important operating data off of the disk and into its memory? Your IBM manuals call the process of getting DOS from disk into random access memory as starting DOS. Many computer systems refer to it as booting. Starting DOS and booting DOS are the same thing. Both terms are used extensively with computers, and you'll soon run across an instruction in an operating manual that simply says boot such and such a disk, or start such and such a program. Here's what that means. Let's assume that you have put a specially prepared DOS disk into your disk drive. When you first turn the power switch onto your computer, the drive starts to run. Your IBM personal computer has a program that automatically starts DOS already programmed into its ROMs. That program has just enough information for your IBM personal computer to know where to look for a disk drive and how to read the first bit of data from a DOS disk in that drive. So you have put the disk in, and the first little piece of information is found, and is loaded into RAM. And all the first piece says is how to load the second piece. And the second piece tells how to load the third piece, and so on, until all the pieces that are necessary are loaded. All the pieces together form what is known as the disk operating system. And so in a sense, it teaches itself how to read itself. It's sort of like pulling yourself up to the moon by pulling on your own bootstraps. Be sure you understand the concept of starting or booting. You'll be asked to boot a disk or to start a disk frequently. Not all disks have DOS on them, so not all disks are DOS starters or boot disks. A DOS disk must contain the instructions known as the disk operating system, the program that controls the computer's entire operations with disks in a uniform manner. You have a master disk that contains DOS that came with your system. It is called the DOS diskette. We'll start a DOS disk now. Find the disk that came with your IBM personal computer labeled DOS diskette and insert it into the left-hand drive above the keyboard. Close the door to your drive. Now reach around the right side of your computer and turn on the power switch. You'll hear the power supply warm up, then beep for test. Notice the flashing cursor on your screen. Next, you'll hear some clicking and whirring sounds coming from the drive, and the red in-use light will come on the front of the drive unit. This is when the DOS information contained on the disk is beginning to load into memory. DOS is starting. Once DOS is loaded into RAM from a DOS disk, you'll see something like this on your screen. Go ahead and enter today's date by typing the month, followed by a dash, then the day and another dash, then the year. Then press the Enter key. You could have used slashes instead of dashes and added a 0 ahead of single-digit numbers as we show here. All of these ways of entering the date would be accepted by your computer. The DOS program will continue to ask for the date until you enter it in a manner it is programmed to recognize. Now the program wants you to enter the time of day. Go ahead and enter the time. You don't always have to enter the date and time when you start your DOS master. You could have simply pressed Enter twice and continued. When you've typed the date and time correctly, or entered through both, your screen will change and this information will be on your display. The title of the program now loaded into RAM is the IBM Personal Computer Disk Operating System. The next line tells you what version of DOS you have and gives copyright information. The version of DOS is the particular updated DOS program that came with your system. Your version may not be the same number as we show here. You may have a version higher than 1.1. All that means is that the people who write the DOS programs may have discovered improvements that could be programmed in and have put them in and made them available. If you have filled out warranty cards correctly and sent them in to IBM, you'll be notified by mail of the availability of updated versions. The next line is the DOS prompt. You should see the letter A followed by the right-angled bracket, then the flashing cursor. The DOS prompt tells you a few things. First, it tells you that it, the disk operating system, is waiting for a command. Earlier, when you did the keyboard exercises, you didn't load DOS from a disk. All you used was what your computer had loaded into active memory from ROM, the language BASIC. The basic prompt. The letters OK were used. OK is the basic prompt. It lets you know that you should respond with a command in BASIC. Another thing that the DOS prompt tells you is what disk drive is the current disk drive. The letter A simply means that the left hand, or A drive, is the drive which will take a command. This is also called the default drive. Essentially, a default value is a value that someone who has written the program feels will be the most common value people running the program will use. In this case, the default of drive A is telling you that disk drive A is ready to go to work for you. Defaults can always be changed. In fact, you can change the default value of drive A to assign your instructions to drive B. If you have two drives, type the letter B in upper or lower case, the colon sign, and press Enter. Do that now. Now type Run and press Enter. This time drive B began running and your screen told you there was a disk error. This happened because there wasn't a disk in drive B. If you have only one drive, it would have begun running. Single disk drive systems will default to that drive if you try to give commands to non-existing drives. The error message also gives you three choices to continue. For now, simply press the letter A to abort the command and return to the DOS prompt. You can easily change back to drive A by typing the letter A, the colon sign, and pressing Enter. Do that now. As you begin to work with your computer, you'll need to go back and forth between drives frequently to save and load data. You have just learned how easy it is to tell your DOS program which drive you want to use. When you started DOS a few moments ago, you had to turn the power switch on after you placed a DOS start disk in drive A. There is another, much faster way to start DOS once you have powered up. Do you remember how to do a system reset? Press and hold down the Control key while you also press and hold the alternate key. Then press the Delete key. Now release them all. The information on the screen disappeared and your computer acted exactly like it did when you powered up just a moment ago. This system reset is the other way you can start a disk program. You have now successfully started DOS and your disk operating system is ready to work for you. In this chapter, you should have learned how to properly care for and use disks and how to start the disk operating system. In this chapter, you'll learn how information is filed on disks, how to run programs from disks, and how to make a duplicate copy of a disk. By now, you must be anxious to run a program on your new computer. Your DOS master disk contains several programs that can be used to demonstrate some of the capabilities of your computer. Most pre-programmed disks have a list of various programs contained on them. This list is called a directory. Some manufacturers call the directory a catalog. To find out just what is contained on your DOS master, type the first three letters of the word directory, D-I-R, at the prompt and press Enter. Notice that a list of various names scrolled up your display. It went kind of fast until it reached the end when the prompt appeared. You can stop the scrolling to examine the first part of the list easily using a command from your keyboard. By holding down the Control key and pressing the numlock key during the scrolling, you can stop the directory information from scrolling off the screen before you've had a chance to examine it. At the prompt, go ahead and type dir again. Only this time, don't press Enter yet. Be prepared to hold the Control key down while you strike the numlock key in order to stop the directory from scrolling too far. This will happen quickly, so if you're ready, press Enter and then the Control and numlock key as soon as the directory starts to fill your display. To continue scrolling, press almost any key. The directory will continue to scroll until it either comes to the end or you do another Control numlock command. Here's a tip. Holding the Control key while you press the letter S key works exactly the same as the Control numlock combination, and it only takes one hand. Take some time now to get comfortable with scrolling and stopping the scroll. We'll show you what information the directory contains when you come back to this video program. Now call up the directory and stop it just before the top line goes off the top of your display. Notice that there are many lines and each line contains quite a bit of information. At the left side of each line is the title of a file on that disk. A file is simply a collection of related information, just like a file folder on your desk contains collections of related information. Files may contain programs. Files may contain raw data. Just as your file folders usually have names, files in your computer are also named. Just as your file folder may be filed in a certain drawer in the cabinet, your computer files may be contained on a specific disk. There may be up to 64 files on a single-sided disk and up to 112 files on a double-sided disk, depending on the amount of information contained in each file. Each file may contain a complete program or a portion of a much larger program. Each file has a name assigned to it by whoever wrote the program contained in that file. The next column in each file tells you the file type, whether the file is written in a language and what the language is, whether it's an executive file or a COM file or a basic file. The next column tells you how much memory space on the disk that file uses. The number represents approximately how many bytes of information that file has. We'll define a byte in Chapter 7. For now, just remember that each number or letter represents 1 byte. The final 2 columns tell you the date and time when that file was last changed. There is another way to display the same directory information if you don't need to know the date and time and amount of memory space occupied by that file. At the DOS prompt, type dir/w and press Enter. Notice that the directory has arranged itself horizontally across the page. This is an optional method of reading a directory that you might find helpful. There are 2 more files that don't show on the directory but are essential to proper operation because they are 2 of the 3 files that contain DOS. These files are IBM Bio and IBM DOS. There is a 3rd file that, when taken with these first 2 DOS files, make up DOS. It does show up in the directory as Command COM. These 3 files for DOS use 3 of the 64 possible directory entries and are contained on every DOS disk. Your DOS master disk contains 2 programs that will enable you to copy disks. Notice on the directory of your DOS master is a file called Format and a file called Disk Copy. Copying a disk is an important procedure. It allows you to make backups of your work so that if anything happens to one of your disks to damage your data, you will have a protection copy to work with. One of the first things you should do when you start to use DOS is to make a backup copy of your DOS master disk. Then use the copy instead of the original whenever you start DOS. This will keep your original master protected and in good condition. You should store your masters in a safe place so that nothing will ever happen to them. Any new unused disk that you purchase for your computer must be specially prepared before anything may be recorded on it. This preparation is called formatting. Some programs refer to it as initializing. Formatting and initializing are the same thing. They are the process of recording some standard information on a disk to prepare it to receive further data. It's sort of like building bookshelves in an empty room before you put in your books. Essentially, your computer must record a standardized pattern on the surface of the disk so a program can be written onto a particular place on that disk. The initializing, or formatting, is a set of tracks laid down that are unique to your IBM personal computer. You can't use disks from other computer systems that aren't exactly the same format as your computer. Nor can disks made on your IBM personal computer be used on any other model computer unless special conversion programs are available. Radio Shack TRS-80 or Apple II or Apple III disks won't work directly on your system. That's why when you see advertisements for pre-written programs, you must see if they are written for your IBM personal computer system without any additional software requirements. You must format every new unused disk before you can use it. If there's a problem on a used disk, you may want to format again, but you'll lose all the data from that disk when you do. Right now, we'll format a disk so you can make a backup of your DOS master. Have a new unused disk ready. At the prompt, type format space A shift /S/1. Then press the Enter key. If your screen doesn't look like this one, but instead has one of these error messages showing, then there's been a mistake in typing. Leaving out spaces or other typographical errors can confuse your computer. Error messages will appear anytime you type a message your IBM can't understand. To give your computer the correct message, simply retype the command. Check it against this one before you press Enter. You will see this message. Do what it says. Remove your DOS master and insert your new disk into drive A and press any key when you are ready. The red in use light will come on, the drive will start to whir, and the formatting process will begin. This will continue for about 30 to 40 seconds, during which time you'll hear some clicking and clacking sounds from the drive. This is normal. You'll also see the message, Formatting, appear in your display. When the formatting is complete, this message will appear on your screen. The line that says, System transferred means that you transferred the complete disk operating system to that disk during the same time you were formatting. There will also be information telling you how much memory space is available on that new formatted disk, how much memory space is taken up by the DOS files, and how much remaining memory for your use is available. Finally, you are asked if you want to format another disk. The program is asking you to respond with a yes or no. The letter Y means yes, the letter N means no. That's a very common way to save you keystrokes, and you'll find it used quite often with commercial software. Type N for no for the time being. When you typed in the format command, you also told the program to do 3 other things. After the word format, you type A:. This told the program to format a disk on drive A. Then you typed a slash sign and the letter S. This told the program that you wish to have the DOS information on that new disk so that it could be a start disk. If you didn't want DOS on that disk, for example, if you only wanted to use that disk to hold files and needed the space DOS uses, you could have left the /S command off. You then typed another slash symbol on the number 1. This part of the command told the program to only format one side of the disk. If you have 320K disk drives, you might want to format both sides of a disk. If that's the case, leaving the /1 command off would have automatically defaulted to both sides with a double-sided disk drive system. You now have a start disk that can load DOS into memory by itself without any additional information. You can check this by doing a system reset. Leave your new formatted disk in drive A and reset by holding down the control and alternate keys while you press the delete key. When the program asks you for the date and time, enter them if you'd like and press Enter, or just press Enter twice. Now call up the directory of this new formatted disk by typing dir and pressing Enter. Notice, however, that the directory has only one file visible. Command-Com is one of the 3 files that make up DOS. The other 2 files for DOS do not show up in your directory, but they are on the disk. Remember, they take up 2 of the possible 64 available files. At this point, you could have copied any disk onto your formatted disk. But since it's important to make a backup of all master disks, we'll copy the rest of the contents from your DOS master onto your newly formatted disk. For this exercise, we'll assume that you have 2 disk drives. If you have only one, you can still copy from one disk to another, similar to the way we just formatted your new disk using one drive. Your DOS manual can give you more information. For now, watch this procedure. Take the newly formatted disk out of drive A and have it ready. This will be called your target disk. Insert your DOS master into drive A. This will be your source disk. Prompt type disk copy as one word, then a space, then the letter A and a colon, then a space and the letter B and a colon. Then press Enter. If your screen doesn't look like this one, you probably have one of these error messages. To correct any error message, simply retype the command correctly. If all else fails, you can do a Control-Alternate-Delete command and start over. Check your correct command against this one before you press Enter. Now, follow the instructions and insert your newly formatted disk into drive B. This will be your target disk. Press any key when you're ready. The program will now read some data from your source disk into memory, store it there, then write it onto your target disk. Once that first batch of data is transferred successfully to your target disk, the program will go back and get another batch and store that in memory, then write it onto your target disk. This process will continue until all the data from the source disk is written onto the target disk. When the disk copy program is finished, this message will appear. The program is now ready to run again if you wish to make another copy. For now, simply type the letter N for no, and the DOS prompt will reappear waiting for your next command. If you want to check and see that the contents of the DOS master did, in fact, copy to the new disk, go ahead and type dir to call up the directory, space, the letter B to get the information from drive B, and a colon, which is used for punctuation. Then press Enter. Notice that drive B started running as the program read the directory off the disk in drive B before it displayed it on your screen. The directories of the 2 disks look exactly alike. Now that you've made a backup copy of your DOS master, you might want to protect it from accidental erasure, or you might want to keep this disk from having any further files saved on it. Remove your new DOS backup from drive B, or A if you used only one drive. You can protect an entire disk similar to the way you protect your videocassettes by breaking off the little plastic tabs. Only in the case of your disks, you need to add a small adhesive label to the disk cover. Here's how you do it. As you hold a disk in the direction you would insert it into a drive, notice that there is a cutout on the left side of the disk. That cutout can be used to write protect an entire disk and its contents. Stick-on adhesive labels are provided when you buy blank disks. They may be placed over the cutout like this. When they are in place over the cutout, you cannot write any data or change the contents of that disk. However, if you do decide at a later time to change a file or reuse the entire disk, you can remove the adhesive label and unwrite protect your disk. For now, find a Write Protect label and cover the Write Protect notch on your DOS backup disk. Some disks come with no cutout. Take a look at the DOS master you received with your system. It was write protected when it was manufactured. You don't want to lose or change the contents of that disk because it is your DOS master. Many commercial pre-written software programs come with master disk write protected. If you tried to copy your DOS master onto a write protected disk, you would have gotten this error message. So far in this chapter, you have formatted a disk and copied a disk. However, suppose you only wanted to copy a single file from one disk to another. There's a program called Disk Copy available on your DOS master which will allow you to copy a single file from one disk to another, or allow you to copy a file from a disk, rename it if you wish, and save it on the same disk. You'll have the opportunity to save and name a program file in Chapter 9. For now, it might be a good time to take a break and play with your computer for a while. There's a program on your DOS master which will provide a short musical interlude. At the DOS prompt, type the word BASIC, then press Enter. Notice that drive A started running and the display changed somewhat. The disk drive prompt disappeared and the display returned to the same format it had when you used it for the keyboard exercises in Chapter 4. You have told your computer that you wish to work with the programming language BASIC while you have available the features of the disk operating system. You'll learn more about languages and operating systems in the next chapter, so for now, just follow along. Now we'll use two of those special function keys on the far left end of your keyboard. At the bottom of your display, a series of numbered words appear. Essentially, these numbered words are there to tell you what the meaning of the 10 special function keys are when you're working in BASIC. Each of the numbers refers to one of the function keys numbered F1 through F10. Each of the words is a particular command associated with that particular key. Find the F3 key and press it. Notice that the word load appeared on your screen followed by open quotation marks. The cursor moved to the right of the quotation marks. At the prompt, type the word samples and press Enter. Drive A began running and then the OK, or basic prompt, reappeared on your screen when the drive stopped. That load command you just did by pressing the F3 key followed by the word samples saved you several keystrokes. You could have given your IBM personal computer the same command by typing the letters LOAD, then the open quotation mark, then the word samples. But IBM designed special keys on the left side of the keyboard to make very frequently used commands quicker and easier to enter. What you actually did when you told your computer to load samples was to look for the first file it came to that had the file name samples and load the entire contents of that file into active memory, RAM. Let's run that file. This time, however, type the letters R-U-N and press Enter. You gave another command to your computer by typing the actual word run, then pressing Enter. You could have saved those few keystrokes by pressing the F2 key directly. Now that this title page is showing, follow the instructions on your display and press the space bar to continue. Notice that a menu has appeared showing you what type of sample programs you can try. Or if you don't want to try any, it tells you to press the Escape key to exit or back out of the samples program. You'll encounter menus frequently during your work with computers. A menu is a list of choices from which you may select one, usually with a simple keystroke or two. Since we want you to have a musical interlude, furnished by IBM, simply follow the directions and press A. Now the music portion of the samples program has been loaded. To continue, simply press the space bar. Go ahead and follow the directions. When you're finished exploring the tunes available to you, come back to this video program. Press the Escape key twice to back out of the music program, once to the main menu, and once more to get back to just Basic, where we can continue. After you press the Escape key twice, you should see this basic prompt on your screen. Type the word System and press Enter. In this chapter, you've learned how to format and copy a disk, and you've run a program from that copied disk. We'll take a look at the software in your IBM personal computer system more closely and answer some questions about DOS in the next chapter. This chapter will introduce you to the various levels of software used in your IBM personal computer. You won't have to work with all the information presented in this chapter every day, but as you progress with your new computer experience and as you read new computer magazines and news articles, you'll find that knowing about the levels of software will help you understand your own system better. Will also help you to understand your IBM's operating system, DOS. That makes your computer one of the most powerful personal computers ever designed. You've heard the word program used extensively when talking about computers. A program is a pre-written set of instructions that tells your computer to perform a specific task. That task may be as simple as telling the disk drive to start running, or as complex as allowing you to do a 5-year financial projection for your company. A program is a set of instructions written in a language that your computer understands. Programs are generally referred to as software. Generally, software can be divided into two categories: application software and operating system software. Application software means applying a program to do a specific function or task, or to solve a specific problem. Application software could be used for inventory control or financial projections for a company. Most of the pre-programmed commercially available software packages, as well as programs you may generate to do a particular task you need done, fall into the category of application software. We'll deal with application software in further detail in Chapter 8. Operating system software is a more internal kind of software. An operating system is essentially a way for your computer to know how to get information from the keyboard, send it to the screen, and to manage the various other devices connected to your computer. Many people think of the operating system as a traffic cop, directing the flow of traffic from many different directions into many other directions. The operating system you are using, DOS, stands for Disk Operating System. Some other operating systems available for other computers are SOS, which stands for Sophisticated Operating System, and CPM, which stands for Control Program for Microprocessors, and there are others. CPM is a very popular operating system that has many application programs written for it. You can add the CPM operating system to your IBM computer. If you do, you would then be able to run any programs written to run on CPM, as well as programs written for DOS. However, whether you are running DOS or CPM, they are both operating systems. The operating system allows you to work with application software and frees you from worrying about the hardware. Software or programs are written in various levels of language, depending on how and where they're used within your computer. Languages are the electronic words that programs use to run. The highest level languages are those that you interact with directly. In fact, these languages use words or instructions that are very much like English commands. Some words you have already used to command your computer are run, load, and save. You ran the music program. You loaded and saved in the copy program. These words are examples of high-level language words. BASIC and Pascal are two of the high-level languages available for your computer. BASIC stands for Beginner's All-Purpose Symbolic Instruction Code, while Pascal is named after a French inventor and philosopher of the 17th century, Blaise Pascal, who invented a mechanical calculator when he was 18. Other languages used in computers today include Fortran, which stands for Formula Translator, COBOL, which stands for Common Business-Oriented Language. Forth, Logo, and Pilot are other languages available for some computer systems today. Each language was designed for a different purpose, and each has its own particular characteristics. There are more high-level languages, but at the other end of the scale, down at the electronic component level, your computer responds only to a series of on and off pulses to do its job. When you type in high-level language words, those words must be read by smaller programs called interpreters. These interpreters translate them into what's called machine and assembly language. It is in the machine and assembly language level where the work is done. Therefore, your computer start disks need an interpreter program to translate the high-level language that you work with into the low-level language that the individual computer components work with. An interpreter program deals directly with language. It might be helpful to think about the relationship between the operating system, interpreters, and the language systems this way. You and your friend are in a new country, and your friend wants to get to a place some distance away. You hail a cab. You are the application software. You have the necessary information on how to get from one part of the city to another, calling a cab. But you can't speak the local language. The cab driver is the operating system software. You ask an interpreter to tell a cab driver where your friend wants to go. But you don't have to tell a driver how to get there. His knowledge of the area and his ability to drive the cab is the operating system. The language you speak to tell the interpreter where you want to go is the high-level language software. The translation that the interpreter does is the interpreter program. Your cab driver, the operating system, puts his foot on the gas pedal. The movement of the gas pedal is the assembly language. That tells the engine that it's time to go faster. The machine language takes over from there to tell the parts of the engine, the crankshaft, and the pistons when to go up and down. Within your computer, machine language is the lowest level of communication. It is at this level that all information and data has been reduced to the on and off pulses that enable your computer to function. These on and off pulses have been formed into a code that represents letters and numbers. Here's how it works. If you were to switch the light switch in your room on, then off, then on, then off again, you would have created a code that could be written like this. In binary coding, you would have expressed the number 10. We won't get into the mathematics involved in binary coding in this program because you won't need to work directly with machine or assembly language to use your IBM personal computer efficiently. However, you might want to know what the 64K or 128K or 256K stands for when it's used to describe the amount of memory in your computer. If so, here's a brief explanation. Early computer programmers decided to assign a number to every letter in the alphabet as well as to certain symbols. And since binary coding reduces every number to a series of on and off pulses, these letters and symbols can now be expressed as a series of on and off pulses. Each individual pulse is called a bit, a positive, or an on pulse is a bit, and a negative or an off pulse is a bit. A standard code was developed that could express all the letters of the alphabet and some signs and symbols by 8-bit arrangements of on and off pulses. We call these different 8-pulse combinations words. They are also called bytes. 8-bit arrangements are used because they can form 256 different combinations, which is more than enough for all the letters, numbers, and symbols. The 8-bit bytes are organized into kilobytes, 1,000 bytes. For technical reasons, however, 1,000 bytes is really 1,024 bytes. But the computer industry rounds off those extra bytes and refers to multiples of kilobytes in 1, 2, and 3-digit numbers. Since we can reduce any number into a code of pulses that consist of either an on or off, positive or negative state, we can use this ability to store these pulses in electronic circuits. There are tens of thousands of tiny storage chambers inside each integrated circuit chip, where simple on and off electrical impulses are stored. Therefore, if your computer has 256K of RAM, it can store approximately 256,000 8-bit words or bytes in active memory, or over 2,048,000 individual on or off pulses. Of course, by storing blocks of bytes on disk, and only using active memory for what you are currently working on, you can gain a tremendous amount of usable memory. Each disk that you use with your IBM personal computer can store either 160,000 bytes or 320,000 bytes, depending on whether you have single or double-sided capable disk drives. For a 320K disk, that's about 2,560,000 on and off pulses, which is roughly equal to 106 double-spaced typewritten pages. This chapter should have given you a better understanding of how the various levels of applications and operating system software interact inside of your computer. You won't have to be concerned with all of this information every day, but a general understanding of it will help you become more sophisticated in understanding how your computer relates and compares to other systems you may read about or someday want to use. In the next chapter, we'll take a look at the many types of pre-written application software available for your computer. You probably purchased your IBM personal computer to solve a specific problem or to assist you with tasks that you had heard personal computers are able to do. This chapter will identify the subjects addressed by commercial pre-written software and show you how to begin to use two of the most common packages. And you'll learn the meaning of more words in this new computerese language you're beginning to understand. There are 6 general categories currently addressed by commercially available pre-written application software: word processing, database management, financial forecasting and budgeting, accounting, telecommunications and electronic mail, and graphics generation. Word processing packages allow you to write letters and reports, correct what you have written before you print it, instantly move words and paragraphs around, merge mailing lists into letters, check spelling errors, even search and replace specific words or phrases. Database management programs allow you to create your own customized electronic file cabinet. You can then access those files in a large variety of ways, largely determined by your own particular needs. The most common example of a database management program is an electronic mailing list file. In that file, you could have the names, addresses, even telephone numbers of everyone you need to correspond with. For example, if you run a small business, you could tell your computer to sort through the mailing list of your customers by zip code. The program would arrange the order of addresses, then print the labels in that order so you have the most efficient stack of envelopes to send to the post office. Or you might want to write to only those customers whose last names begin with the letter B. Your database manager could give you a list of those customers almost instantly. Essentially, a database management program files data and information in such a way as to allow access from many different directions. A word processor application program, on the other hand, stores data sequentially, usually allowing access in only one direction. But suppose you wanted to merge a mailing list and a form letter. You could get another software package that would allow that merger to take place. You've heard the names of many of the best-selling application software packages. You probably have one or more of them yourself. EasyWriter 2 and WordStore are popular word processor packages available for your computer. VisiFile and VisiDex are 2 database systems that are extremely flexible and adaptable to your own needs. VisiCalc and SuperCalc are 2 of the best-selling financial forecasting and budgeting packages. They allow financial projections and manipulations on numbers to be performed quickly and easily. Peachtree Software and BPI have accounting packages designed for businesses. Most systems for accounting provide general ledger, accounts payable, and accounts receivable and payroll functions. Telecommunications and electronic mail offer another exciting way to use your IBM personal computer. With the addition of a modem, which stands for modulator-demodulator, you can literally use the telephone line coming into your business or home to call up another computer. That other computer can be another personal computer or a giant mainframe that offers a broad range of services to personal computer users. You may have heard of services such as CompuServe, The Source, and Dow Jones. They offer access to more than 1,000 databases where information is stored and available to you on your computer. You can get breaking world, national, state, and local news and sports from UPI, stock market quotes from Dow Jones, shop at home from a computerized catalog of products, send mail by computer to other parts of the country, check airline schedules, read movie, wine, and restaurant reviews, even sell and buy almost anything on computerized bulletin boards. Many local newspapers around the country are available on your computer when you use it as a remote terminal, tied to another computer. You can even send electronic mail to other personal computer owners and receive mail from them. Visitrend and Visiplot are examples of graphics generating systems. With graphics packages, you can create graphs, charts, architectural drawings, in fact, almost anything visual that you could imagine on your display screen. Then, with the addition of a printer or a plotter, you can produce what's on your screen on paper or overhead projection cells in color or black and white. There are even some packages that combine various categories in one integrated program. Context MBA and 123 are packages that include financial forecasting, graphics, database, word processing, and telecommunications in one package. And then there are educational, personal, and entertainment software packages. People of any age can expand their horizons, create new opportunities for themselves, and access an unlimited wealth of information. Perhaps one of the most popular packages in all of personal computing today is VisiCalc. It has been called the tail that wags the dog because so many personal computers have been sold so that people can use VisiCalc. VisiCalc is produced by a company called VisiCorp, which offers a wide range of software packages. VisiCalc is an electronic spreadsheet. It allows users to input letters and numbers at intersections of columns and rows. VisiCalc's fantastic power lies in its ability to allow formulas to also be placed anywhere on the sheet. When you first open the package for VisiCalc, you notice that there is a ring binder, 2 disks in their own packages, a folding reference card, and a warranty booklet. That is a very typical packaging system for software for your computer. The 2 disks are one main program disk and one for backup in case anything happens to the first one. The user's manual is very comprehensive. It shows you what every possible command does when you run VisiCalc. The VisiCalc program disk is not a start disk. The first thing you should do with VisiCalc is add the disk operating system to the master disk. VisiCalc does not come with DOS on the master. Do remember to have a disk already formatted if you want to save any work that you might generate with VisiCalc. One of the most common first-time user errors occurs after someone has put a lot of time and effort to build a sizable amount of data. They get ready to file that data on a disk only to discover they haven't formatted one for that particular program. They must lose their work to format a disk. Here's a tip. When you get a new box of disks, go ahead and format all of them. Then you'll always have formatted disks ready. The first things you're going to have to do when you start to use a commercially prepared application program is to load that program into RAM. There are 2 ways to load applications programs. You can put the DOS information on your application's disk and load both programs from that one disk. Or you can load DOS from a separate DOS disk and then load your application's disk. The first way to load an application program is to start the program directly, using either AutoStart or a Control-Alt-Delete command. This method assumes that the disk operating system is contained on the application program's main disk. Since most applications program manufacturers don't provide the IBM disk operating system on their program disk, you must install DOS on their disk first, before you can use it as a start disk. In addition, some applications programs require that you add configuration data to your program disk master. This lets the program know what specific kinds of peripheral devices you may be using. These applications programs usually give you a set of simple procedures to follow in the front of their manuals. They'll take you step by step through the procedures to install DOS and the peripheral configuration data onto their program master disks. Check the first few pages of the manual of one of your commercial applications programs for these procedures. When you've installed DOS and configured your application's program, it's faster and easier to use these programs this way. To load them into memory, you'll only have to insert the master disk, then turn the power to your computer on or give a system reset command. Sometimes your dealer or someone else will have installed DOS and configured your disk for you. If this is the case, you're ready to begin to use these powerful applications programs right away. If your dealer hasn't already configured your disk, you may want to thumb through the procedures at this time. Go ahead and find the installation procedures in the front few pages of one of your application's manuals now. When you familiarized yourself with where they are, come back to this video program. The other way to load an application program is a two-step procedure. First, you would start DOS from your DOS disk. After that, you would remove the DOS master and insert the application's program disk into your drive. Then you would give your computer a command to load that application's program. That command may be buried deep inside your application's program manual. Each application program has its own unique set of command menus. Once you understand the basics of your IBM personal computer, you'll be able to adapt to new programs easily. Here's a helpful reminder for you. Whatever the application's program you're using, don't forget to back up your disks. It's a good idea to save your progress on disk every 10 or 15 minutes. Remember, the work you're currently doing is held in volatile memory. That means that any power failure, no matter how brief, could erase any work that you haven't saved. Some users make it a habit of frequently revising a backup disk as well. All it takes is a tiny bit of dust to cause problems with the disk. If you have a backup, you could save yourself hours, maybe even days of work. There is also the copy protection feature. Some programs can be copied using the standard disk copy program available on your DOS master disk. Other programs may be so proprietary that the packager may want to prevent unauthorized copies. If a program isn't copyable, be extremely careful with both your master and backup disks. You might not be able to get replacements very quickly. Be sure you fill in whatever licensing agreements or warranty cards that come with an application's package. Sending in these cards will help packagers identify you if you do need to get. Some programs will have their own copy programs built in so that you can stay in that program if you need to make a copy. Some will even have a format program included so you don't have to run the DOS master disk to format a volume. And many software manufacturers even have hotline telephone numbers for users' questions or problems. You should now be able to use your computer for almost any kind of common application you may have purchased it for. However, you may want to learn about programming to develop your own software, customized to your own application. If that's the case, the last chapter of this tape will give you a very brief introduction to programming. One of the common myths about computers is that you need a very extensive background in mathematics to program a computer. That isn't so. The following chapter will show you that clear, logical thinking is the only prerequisite for successful computer programming. In this chapter, you'll learn what a program is and how to write a few simple programs. Writing programs is a specialized aspect of using a computer. Remember, you don't have to know how to program to use your computer. If you do, however, you can increase your productivity and enjoyment of your personal computer. Essentially, a program is a logical and sequential list of orders you give to a computer to tell it how you want it to do what you want done. The important thing to remember about writing new programs is to understand and plan each and every step that must be done. Your computer will do exactly what you program it to do, nothing more. You must tell it all it needs to know to accomplish your task. If you leave out even the smallest instruction, your computer will not run a program correctly. Remember, your computer is really very dumb until you tell it what it needs to know to operate. You're going to write a few programs now. Go ahead now and start your DOS disk. It will be less confusing for you if you work in all uppercase letters in this chapter, so when the DOS prompt appears, press the caps lock key once. Then type the word BASIC and press Enter. Your disk drive started and loaded the disk version of the language BASIC into RAM so you can work with it. Remember, earlier in this program you had loaded Cassette BASIC. Well, Disk BASIC does everything Cassette BASIC does and allows you to use the DOS system for files. Advanced BASIC is also available on your DOS master. It allows you to do everything that Cassette and Disk BASIC do, but also has some commands like circle, paint, and draw for use if you have the color graphics monitor adapter. For now, we'll work with Disk BASIC. It would be helpful to have a clear screen to work on, so at the prompt, type the letters CLS and press Enter. The letters CLS stand for Clear Screen and do just that. The word CLS is a reserved word. It is one of the many specific letter combinations that form words that your computer has been programmed to understand. These reserved words are frequently used commands that would take many more keystrokes to execute. Rather than requiring you to type in several lines of instructions to clear the screen, typing CLS Enter simply does it all for you. As you proceed through this chapter, the message syntax error may come up on your screen. For example, type any gibberish and press Enter. Your computer responded with syntax error, which means, I don't understand that word in the language I'm using. When you get a syntax error message, simply retype the line correctly. This will eliminate the error. Now type the word new and press Enter. New is another reserved word that tells your computer that the next set of instructions it receives from the keyboard will be a new program and that it should forget any previous programs. Typing the word new at the prompt clears the memory. Here's our first program. Type this exactly as it appears. 10 space print space bar shift quotation mark HELLO shift quotation mark. Then press the Enter key. Be sure you use the double quotation mark sign and not the apostrophe. When you enclose words inside of quotation marks, the program will later print out what you have written within the quotation marks exactly as you have written it. If you make a mistake on a line and have already pressed Enter, just retype the entire line correctly. This will replace the old line in memory and totally eliminate the error. Now type 20 spacebar print spacebar shift quotation mark goodbye shift quotation mark. Then press the Enter key. Now type 30 spacebar end Enter. Now type list Enter. There is a new list of what you have just entered. Now type run Enter. Your computer followed your instructions and printed exactly what it was told to print. Nothing less, nothing more. Now type list Enter. Let's examine the program. The number 10, number 20, and number 30 are called line numbers. They tell your computer the order in which commands should be executed. It is a common programming practice to leave blocks of numbers between line numbers. For example, you could add a line 11, 12, 13, 14, etc. through 19 at any time. Effectively, you have 9 more usable lines between each line when you number in multiples of 10. By allowing room for extra commands later, you can save yourself a lot of time with revisions. For example, type the line 15 space print space shift quotation mark eat E-A-T shift quotation mark Enter. Now type list Enter. Notice how the line numbered 15 has been added in the proper order to your list. Now type run Enter. And the program was executed exactly as you modified it without rewriting all the old lines. Incidentally, the word print, as we've used it here, means output to a device. In this case, your monitor screen. It doesn't necessarily mean to print only on your printer. If you make a mistake before you press Enter, use the backspace key to erase the line and retype it correctly. If you've already pressed enter and realize you've made a mistake, as we did when we typed the word eat, simply retype the line number and the rest of the line correctly. The new correct line will replace the old incorrect line in memory. Now type new, enter. Then 10, spacebar, print, spacebar, 5, shift plus sign, 4, enter. Then type 20, spacebar, end, enter. Then type run, enter. Notice that the program added the 5 and 4 and printed only the total. That's a simple example of an arithmetic function already available in a language program. It might be of interest to you to know that language software has certain functions already programmed and ready for your use. The addition you just did is available in BASIC and BASIC A. Other operations most basic language versions offer are subtraction, multiplication, division, and raising to a power. Now let's get rid of that program and do another one. Type new, enter. Then type 10, spacebar, print, spacebar, shift quotation mark, I, spacebar, love, spacebar, shift quotation mark, semicolon, enter. Then type 30, spacebar, go to, spacebar, 10, enter. Then type 20, spacebar, print, spacebar, shift quotation mark, U, shift quotation mark, enter. Now type list, enter. Notice what happened. The list command automatically arranged each line in your program in the proper numerical order. You'll find that a very useful feature as you learn to write longer and longer programs. Now type run, enter. Don't panic. Just type a Control-Scroll-Lock to stop the program. That go-to command on line 30 caused a loop to be created. Your computer merely did what it was told, went back to line 10 and did it again, and again, and again, until you stopped it. Let's take a moment and examine a few of the things we just did. First and foremost, you wrote 3 small programs and then ran them. Each time you wanted to start a new program, you typed new. That command told your computer to forget forever any previous program in memory and lets you start a complete new one. You then assigned a number to each line. This told your computer in what order you wanted the execution to take place. You also asked your computer to list the program you had just typed in. When it did list, it automatically placed any lines that were typed out of sequence in that you desired, since you gave each line a number. Of course, you asked the computer to run your new program. The last program had what's called a loop in it. When the program came to the line that had a go-to command, it looped back. The loop just kept going round and round until you interrupted the program with the Control-Scroll-Lock command. When you did the Control-Scroll-Lock command, your computer told you where it stopped. You used several reserved words when you were programming: run, list, go to, new, and print. There are many other reserved words that are available to help make programming faster and easier to understand. However, because some words are reserved for certain functions and commands, you must be careful that you don't use them out of context when you are programming. A complete list of the reserved words for a particular language usually comes with a language reference manual when you purchase that language program. Let's try a new program. Clear your screen by typing CLS, enter, and clear the memory for this new program by typing new, then pressing enter. Here's our next program. type 10, space, N, space, equal sign, space, value 1, enter. Then type 20, space, N, space, equal sign, space, N, space shift, plus sign, space, 1, enter. Next line, type 30, space, print, space, N, enter. Then type 40, space, go to, space, 20, enter. Now list your program. Now run your program. Remember how to stop it? Control scroll lock will do it. In this program, you assigned a variable number to a letter, then told your computer to print the number that represented the letter. You also told it to increase the value of the number by 1, each time it looped back to line 20. In computer programming, any value, number, or letter on the right of the equal sign gets put into what's on the left of the equal sign. Don't let your previous experience with algebra fool you here. We'll do one more, somewhat more complicated program for now. Follow very carefully and type in each line as we show it. If you make a mistake on a line, simply retype that line's number and retype the line correctly. Ready? Here goes. Clear your screen. Type new, enter. Now type 10, space, input, space, shift quotation mark. What is your name? Space, shift, quotation mark, semicolon, A, shift dollar sign, enter. Check it against hours. Now type 20, space, input, space, shift quotation mark, name and animal, space, shift quotation mark, semicolon, B, shift dollar sign, enter. Is it exactly like this one? Then type 30, space, print, space, shift quotation mark, hello, comma, space, shift quotation mark, semicolon, A, shift dollar sign, semicolon, shift quotation mark, space, you look like a, space, shift quotation mark, semicolon, B, shift dollar sign, enter. Last line, type 40, space, end, enter. Before you run this program, list it. Type list, enter. Check your list against ours one last time. Now run it. Follow the directions you have programmed in and answer the questions as they come up. Type run, enter. That's the last program we'll do here. It's more complex than the earlier ones, but by programming standards, it contains a lot of common functions and commands that you will soon discover come easy to you once you become better acquainted with basic programming. That's what computer programming is all about. Step-by-step instructions on how to solve a problem in logical sequences written in computer language. Let's take a moment and examine a few of the things we just did. Generally, a program has 4 parts. Part 1, initialization. Part 2, the body. Part 3, the output. And Part 4, the conclusion. During Part 1, the initialization, constant and variables are defined and given starting values. Part 2, the body, is where the work is done. In this part, the program will ask for data from an input device, such as your keyboard. It will then process that new data with respect to the set of constant and variable values that were programmed in the first step. Then the program will make any decisions that it has been programmed to make. It will then send the results of that computation to an output device, such as your display screen or a printer. This is the third part or output stage of the program. Part 4, the conclusion, is just that, the end of the program. And so you see, we're right back to where we started in Chapter 2. The computer fetches instructions from memory, performs those instructions, adds information if required from input devices, and displays or transmits the results of that process through output devices. We'll do one last exercise. Since that last program was kind of fun, you might want to save it and have your friends run it. You'll create a file on disk so that you won't have to rewrite it when you want to use it again. Find your backup system master. When you do, remove the Write Protect label that you put on it earlier. Remove the DOS master from drive A and replace it with your unwrite protected backup. Press the special function key labeled F4. When the word save followed by an open quotation mark appears, type a name for your program. Let's call it insult. Then press Enter. Your drive should start whirring for a few seconds as the program is written onto your disk. When it stops, type System and press Enter. At the DOS prompt, type DIR and press Enter. When the directory comes up, find your new file labeled Insult. Now get back to Disk Basic by typing Basic and pressing Enter. When the Basic prompt appears, find the F3 key and press it. When the word Load followed by an open quotation mark appears, type Insult and press Enter. Notice that the disk drive ran for a few seconds while your program Insult was read from disk into RAM. Now press the F1 key followed by Enter. Notice that the program list appears. Since you have saved that program, you should write protect your backup DOS master. Go ahead now and remove the disk from the drive. Replace the write protect label over the notch and put the disk back into the drive. Now get back to the DOS level by typing System and pressing Enter. You can try to delete or erase that file called Insult by typing either DEL followed by the file name or Erase followed by the file name. Go ahead and try to delete the Insult file by typing DEL space Insult period BAS and pressing Enter. Notice the drive went on for a few seconds while the program looked for the Insult file and tried to delete it. However, because you replaced the Write Protect label, the only thing that happened was the error message telling you that the disk was write protected. Your computer asks you to either abort your command to delete the program, retry, or ignore your command. In this case, just type A and the command will be aborted. You'll be back at the DOS prompt level ready for another command. In this chapter, you have worked with a version of the programming language called BASIC, originally developed by a company called Microsoft. You also interacted with the DOS system again. Programming can be extremely complicated, but not necessarily difficult once you learn the language. Essentially, it is very straightforward and logical. If you feel that you'd like to go further with programming, get a hold of any of the currently available programming manuals, a language software program for your computer, and have at it. It can only be learned by doing. But always keep in mind, you don't have to know how to program to get full value from your personal computer. Other people are writing programs every day that will extend the usefulness of your computer for years to come. You now have learned all you need for years of very rewarding and interesting interaction with your personal computer. As a new personal computer user, you have just begun an exciting journey into the information age. What we have presented in this video program is an overview of your system and enough hands-on experience for you to learn some of the essentials of operating your new IBM personal computer. It is not complete by any means. You could spend days, even weeks, just following the tutorials presented in the manuals that come with the system. However, we have found that most people want to get going right away. You'll pick up a lot of new information once you get started. If you have followed each chapter and done each exercise successfully during this program, you have learned the fundamentals that will enable you to begin to use commercially available software packages on your new computer system, right now. If you still feel a little shaky in some areas and feel that you want to review some sections further, simply rewind this program to that section and play it again. We have presented a lot of information in a short time and don't expect anyone to get it all the first time through. We wish you luck with your personal computer experience and hope that the time we've spent together helps you to enjoy a very rich and rewarding lifetime of computer-assisted activities. Thank you very much.